Good afternoon, friends. So, in previous video, we have learned about some basic terminologies regarding equilibrium. So, today we are going to solve some roller equilibrium problems. So, here is one problem. It's a simple one. So, will read problem first. Determine the horizontal force P to start the wheel over the block and also the reaction at the corner of the block. Okay, so what we have to do is we have to determine this horizontal force P, okay, and the reaction at this corner of the block. Okay, so first of all, just figure out what are the things given. So the given values are weight of the block, weight of the this sphere wheel is 1000 Newton, radius of this wheel is zero point 0.4 meter. Okay, so what we have to do is we have to first draw FBD for this shape. Okay, so for that case I have drawn some the bigger one value, bigger one shape. So this is your wheel, this is your block. Okay, so very first thing is this P force is known, right? We have drawn that thing. Then W. Okay, so W is nothing but the weight of this wheel acting at the center. We have drawn that thing. Okay, so next is this, there are two surfaces in contact, like this is wheel. At C point, this wheel and block is touching each other. At point A, this surface and this wheel is touching each other, right? Then that means there are two reactions we have to show, or what else? So read question carefully. The question itself will give us the hint about this problem. They have said the wheel over the block. To start the wheel over the block, that means if we'll consider this as a block, this is as a wheel. Okay, so what they are asking, this wheel is going over, we are pulling this block over, we are pulling this wheel over the block. That means this wheel is losing contact with this surface, right? So it is gonna move over the block. That means this is not in contact with each other, only this will be in contact. Okay, so got it? That's why we are not shown any normal reaction over this surface. Okay, because they are losing the contact with this surface, right? Okay, so like this way we can say there are these two forces we have drawn. First this P. Now if I'll consider this as a line of action, so if can I transfer this force over this point, right? Law of transmissibility. So I've drawn this P point, this P force and this W. Now if we consider this is in equilibrium, that means this, if these two forces are crossing at this point P, they are meeting at this point P, that means the third force is definitely gonna pass through this point only, and then these three forces are making this body in a equilibrium state. Okay, that means this reaction is gonna definitely pass through this point B. So I have drawn this at this point RC. Okay, now the thing is, what is this angle? So that we have to find out, correct? So now what I'll do is, if this is your reaction, I'll consider this reaction is passing through this P point. So this is alpha angle. If it is making an alpha, this alpha with horizontal and this theta is with vertical. Okay, so either of the value we can find out. So we'll consider, if I have to find out this alpha, the possibility, no, I'm not getting this alpha if any way of this geometry. If I consider this as a theta, this is nothing but the alternate angle theta, opposite angle. So this theta and this theta, if I'll consider this B Q C as a triangle, then this theta I can find out, and this is nothing but the opposite angle, this thing. So I can find out the value of normal reaction of this C point, any of the value, like vertical or horizontal, any of the way I can find out. So now I'll consider this triangle BCQ, this triangle BCQ. Okay, so what is this length? OB is nothing but the radius. OA is nothing but the radius. We know the value of this block. This height of the block is 0.1. So this QA is 0.1. So OA is total value is radius. So can you find out this OQ value? Correct? So this minus this is nothing but this value OQ. So we got this value of OQ is nothing but 0.4 minus 0.1. So it is 0.3. Okay. Now the next value is, we got this. So the total height we can find out. This total value is nothing but radius plus OQ value. So for, if I'll consider this triangle, that will, this value I know. But if I'll consider this as a right angle triangle, this hypotenuse, still we are not aware about this hypotenuse. So what else we can do is, we'll form one more triangle, OCQ. Okay, this triangle. Now tell me, OC is nothing but the radius, right? So we know the value of OC, we know the value of OQ. So can you get the value of QC? This is nothing but right angle triangle. So can get this value like this way. OC is nothing but under root of OQ square plus QC square. OC is nothing but OQ square plus QC square, right? Right angle triangle. So like this way I figure out this value of QC. Now QC is known, BQ is known, we have to find out this theta. So it's very simple. This is nothing but from triangle BQC we can get the value. Tan theta is nothing but opposite upon adjacent. So opposite upon adjacent, and then we got the value of Q, that is nothing but 20.37 degree. So that value we got it. This is nothing but this. It's nothing but the opposite side theta. So now our shape is become like this way. It's W, P and 20.37 degrees RC. So this shape is converted into this FBD of the only forces. Okay. So now these are 1, 2, 3 forces acting on this body. Here we can go ahead with the equilibrium equation, that is nothing but summation of f of x is 0, summation of f of y is 0 and momentum is 0, right? Or you can go ahead with the triangle law or Lami's theorem. So we'll consider first the equilibrium equation only. So if I'll consider this summation of f of x, so what is summation of f of x? First consider sign convention, right hand side positive, left negative. Okay, so for this case, this is making some angle, so we have to resolve it. Okay, so now when we have to resolve something, when any force, the angle is with respect to vertical. So with respect to angle, that means this side becomes your cos and the remaining one is sine. Okay, so it is not like that, the vertical one is always sine 1. Okay, so here the angle is with respect to vertical, so this vertical comes cos 20. Okay, so now we have to go ahead with the horizontal reactions first. So summation of f of x, so this we have to resolve horizontally, so it is going towards negative side. So negative RC sine 20.37. Remember, horizontal is not always cos, that is not with respect to the horizontal or vertical, that is with respect to the angle making with vertical or a horizontal. So here the angle is with vertical, so this side becomes your cos. So this is minus RC sine 20.37 plus P. So this is your first equation. Then summation of f of y is nothing but RC cos 20.37 minus W. So this W, the value is known, that is nothing but 1000 Newton. So this is nothing but here 1000. So RC, you get the value of RC, put this value in this equation, you'll get the value of P. So this way you can solve the problem, or you can go ahead with the Lami's theorem or triangle law. That is nothing but RC, the force, into opposite of sine of angle. So RC opposite of sine of angle is nothing but sine of 90. So RC divided by sine of 90 equal to W divided by sine of opposite of angle. Opposite of angle is nothing but this is 90 plus 20.37. So W divided by sine of 90 plus 20.37. then this P divided by opposite of angle. So can I say it is 180 minus 20.37 is nothing but this remaining angle? Yes. So this is nothing but P divided by sine of 180 minus 20.37, and here the value of W is known. So this is 1000. So you can equate this both the sides and you'll get the value of P, that is nothing but 372 Newton. So plus or minus 1 2 difference is okay. So this is nothing but how we can solve this problem. So please go ahead in detail with this problem. Please solve this problem, draw proper FBD for this problem. Okay, I will share some more problem with you in the next video, so stay tuned. Thank you.